exponent on m? You can't see it, but it's there. Jack? It's a 1. Now watch this. If I have m to the third over m to the third, okay? Remember, our rule says if they have the same base, what do? Subtract their exponents. So we write m to the 3 minus 3, which is m to the what? Not first. 0 power. Well, what in the world does that mean? Let me show you another way. If I have m cubed, that means m times m over m cubed, which is m times m times m. What happens here? What happens to this m and this m? What do we, when we cancel, what do we put in its place? No, when you cancel things, what do they become? 1. That's a 1, that's a 1. Cancel, cancel, 1, 1, cancel, cancel, 1, 1. So what do we get left? 1 times 1 times 1 is not 3. 1 over, which is anything to the 0 power is 1. M squared over m to the 4th power. Our rule says to subtract their exponents, so it's m to the 2 minus 4. What do we get? M to the what?
-2.
We cannot keep negative exponents. There is a rule that says what to do, and here's what you need to look at. How many m's are in the numerator?
4.
Numerator. How many in the denominator?
4.
How many cancel?
2.
Those 2 and those 2, right? What are we left with on top?
4.
What? 1 over m squared. Anytime you have a negative exponent, you cannot keep it as a negative exponent. That's not simplified. It goes into the opposite position, which if it's in the numerator as negative, it goes into the denominator as positive. So a to the negative n power is 1 over a to the n power. Can we have a negative exponent in the denominator? Nope, it's not simplified. So where does that one go? Goes up into the numerator. So we would have 3m to the 3rd power over 1, but we don't need to leave it as over 1. Okay? So it says write using only positive exponents. Number 1 says 4 to the negative 3rd power. Well, that's 4 over 1, right? We cannot have a negative exponent in the numerator. So we're going to write this as 1 over, take the base with it. The base is what?
4.
So it's 1 over 4 cubed. You are going to use this a lot in higher level math. Okay? Look at number 2. M to the negative 5th, n to the 0 power. Well, come on, guys. Look at that one. And what can you tell me right off the top of your head? Look at it. What can you tell me? Jared?
N to the 0 is 1.
Yes, n to the 0 is 1. I can replace this with times 1. Because anything to the 0 power is 1. And then I'm left with m to the negative 5th power, but that has a negative exponent. So what should it become? Well, it can't keep a negative exponent, and it's in the numerator right now, right? So it's going to become 1 over m to the 5th power. So 7 to the negative 3rd. Raise your hand and tell me what is the answer to that. Hudson?
1 over 7 to the 3rd.
1 over 7 to the 3rd. You're right. And if you needed to, you could multiply 7 times 7 times 7, right? Look at number 13. Or no, not number 13. How about number 3? It says 13x y to the negative 8th power. I lose some people here. Okay? What is the exponent on 13? 1. You can't see it, but it's there, right? It's a 1. What is the exponent with x? And the exponent with y is negative 8. Which one is the only one that needs to move? The y to the negative 8th power. So 13 and x stay in the numerator. We drop the y to the denominator, and it's y to the 8th power. Do not confuse the coefficients with the bases. So number 4 says 2z to the negative 2nd power. What is the power on the coefficient 2? 1. Is that going to move? No. The only thing that moves is the z. So it's 2 over z squared. Jackson, what'd you get for your answer here?
3y over x to the 4th.
How many of you got 3y over x to the 4th? That is correct. Okay, because that's the coefficient. That has an exponent of 1. It says write without using a fraction bar. Well, what's the power with 100?
Q squared.
Nope. Christian?
1.
1. This is how you want to do it. You're going to write 100 to the negative 1st power. But I will tell you, doesn't 100 factor? Prime factorization is 10 times 10. That's not prime though, is it? That's 2 times 5 and 2 times 5. So this you would not get all the points for. It's really 1 over 2 squared times 5 squared. Right? Isn't 2 times 2 times 5 100? Okay, now we got to write it without the fraction bar. Meaning, I've got to bring this back up to the numerator and this back up to the numerator. Well, if I bring them back up to the numerator, what kind of exponents are they going to have? So that's 2 to the negative 2nd times 5 to the negative 2nd. A cubed over c to the 5th power. Here's your fraction bar. A to the 3rd power is perfectly fine because it's in the numerator, right? This is in the denominator. I cannot keep it there because it says write without using a fraction bar. So I keep the a cubed and I multiply it by c to the negative 5th power. Number 8 and 9, do those. What's the prime factorization of 18? Just give me the final answer, Maria.
2 times 3 times 3.
So I'm going to write 2 times 3 squared, right?
Yeah.
So what does that become without using the fraction bar? Well, the 2 has to come to the numerator, right? So it's 2 to what power? Negative 1 times 3 to the negative 2nd. 3 over c squared, Hannah.
3c negative 3c to the negative 2 power.
Yep, 3c to the negative 2nd power or 3c to the negative 2th power, right? Oh, guess what? We're gonna mix up everything now. Love these problems. Find the product. What does product mean? Or quotient. What does quotient mean? Division problem. Number 10 says 7n to the negative 4th over n, or divided by n. You guys, I told you yesterday you have to show me the rules, right? Right? This is what we're going to do. These two have the same base, right? What's the power in the denominator?
1.
So I'm going to rewrite this as 7n to the negative 4th power minus 1. I take this one up and I subtract it. Do you have to show this to me? If you do not show me the rules, I'm going to count the problem wrong. I don't care if you think you can do it in your head. I don't know that. So we get 7n to the... No, keep change opposite. Negative. So now we can't have a negative exponent, so it becomes 7 is the coefficient. It has an exponent of 1, so it stays there over n to the 5th power. Number 11 is a product, right? 3 is the base. 3 is this one's base. They have the same bases. They are being multiplied together. What does the rule say to do, Maria? So we're going to go 3 to the 10 plus negative 7, which is?
3.
And we're good, aren't we? That doesn't have a negative exponent, does it? No, we're good here. All right, last problem. Number 12, if you look in the denominator, that has a 1 there. So the coefficients are good, right? So we're going to leave it 7. These D's are the same base. So I'm going to write, the rule says to bring it up here and subtract. I'm going to write D to the negative 4th minus 2. The E's are the same base as well. So I'm going to go E, it says to bring it up there and subtract. E to the 3rd minus negative 5. Now simplify. This is 7. Okay, D to here, I'm going to do keep change opposite now because it's subtracting, right? So I get D to the negative 6th power. E, oh, I'm going to keep change opposite there. E to the 8th power. Am I done? Nope. Because we have a negative exponent here. So 7 stays in the numerator, so does E to the 8th. And we put D to the 6th in the denominator. Do you have to show me the rules? Yes, you do. If you don't show me your work, I am not giving you credit. Okay? So, we are going to practice these problems. We're going to do page